I am Dr.S.KAMALAKANNAN, Professor, EEE, SA Engineering College, Autonomous, Chennai 77. Today my topic is electric circuits and my subtopic will be two-port networks. Thought sharing. Working hard on something we don't care about is called stress. Working hard on something we do care about is called patient. So as mentioned earlier, my topic will be electric circuit and then my subtopic will be two-port network, which is coming under GATE EE 2025 syllabus. Fine. So this will be content of today's presentation. First I'll be taking into account introduction. In introduction I'll be telling what is a port and then the types of ports. Right. Next will be two-port port and then its parameters. So you have many parameters. Here I am taking 4 parameters into account. One will be Z parameter, otherwise called as open circuit impedance parameter. 2 is Y parameter or short circuit impedance parameter. 3 is a H parameter or hybrid parameter. And finally T parameter or transmission parameter or ABCD parameter. Right. Then third, I will be concentrating on conditions for symmetry and then reciprocity. And next I will be proceeding with the applications and conclusions. And last but not the least, previous year questions I will be discussing. Fine. What is a port? Port is a one which will be receiving the current and then will be delivering the current. That is actually port, right? So port are of two types. Okay, one is a one port and other is nothing but a two port port. So what you see here is a one port port. Okay, I'll be having only one current here. Okay, as mentioned earlier, what happens means I am taking only one current, that is nothing but I. Okay, that the current is getting inside this two-terminal linear network and then the same current is coming out. Okay, so here you will be having two terminals. Okay, one is nothing but 1 and other is nothing but 1 dash. Okay, so this can also be otherwise called as a two-terminal network, right? So what are the examples where you are applying this means you are using in resistors, inductors and then capacitors. Why? Because means is all these resistors, inductors and capacitors will be having two terminals in it, right? So the figure below is the representation of this one port network. So what is the purpose of this two port network? Yes, see, any electrical network, if you are representing by means of an equivalent model means it will be very easy for us to analyze it. So for that purpose what we are doing means we are going for this two port network. So what is two port network? What is the difference between one port network and then two port network? In one port network you had only one port and only one current, but here you will be having two ports and then two currents. Okay, in one port current I1 is entering, the same current I1 is leaving. Okay, what about the terminals? One is 1 and other is nothing but 1 dash, right? So what about this side? Yes, this side you are having another port, okay, but a different current, that is nothing but I2. So this current I2 is entering, the same current is leaving. So what about the terminals here? It is a 2 and then 2 dash. So previously it was 1 dash, here it was a 2 dash, right? So totally you will be having 4 terminals. Okay, 4 terminals, right? Fine. So here this one will be called as port 1 and this one will be called as port 2, right? So port 1 will be having a voltage V1 and then port 2 will be having voltage V2. Then what about the current? Is you have one current I1 for port 1 and then another current I2 for another port. So you will be having totally 4 variables here as mentioned, right? 4 variables V1, V2, I1, I2. So out of this 4 variables, what I am going to do means is 2 I am going to make it as an independent variable and another 2 I am going to make it as a dependent variables. So when I use this, ultimately I will be getting 6 paths of equations. So these equations will represent a dependent variable in terms of independent variable. That point is very, very important, right? All these 6 equations is going to represent dependent variable. Okay, as the name indicates, it is going to depend in terms of what means independent variables. And next very important thing is I'm going to take the coefficient of independent variables. So the coefficient of independent variables will be called as parameters. Okay, so that parameters here is are of 4 parameters. Okay, that will be explained in the next slide. Fine. So when you take the two-port network parameters, okay, I can have 4 types. Okay, that is, one is Z parameter, okay, which is otherwise called as open circuit impedance parameter. I'll justify while I'm taking the particular topic the name. The next is Y parameter or short circuit impedance parameter, right? Third one is a H parameter or hybrid parameter. Okay, then the next one is G parameter or inverse hybrid parameters. Okay, then the last one, but not the least one, that is nothing but T parameter or transmission parameters or ABCD parameters. Okay, fine. So what about this application of two-port network? One-port network was used in two-terminal devices. Okay, this two-port network will be used in the construction of filters, attenuators, equalizers, and then impedance matching networks. So as the name indicates, filter will filter out the unwanted ripples, attenuator will convert the strong signal to weak signal, equalizer will equalize the volume of the frequency, okay, in audio signal. Then what about this impedance matching? Means that it take place between two circuits. Okay, it will be matching the impedance between the two circuits, right? So as mentioned earlier, what about the application? Means is I'll be using it for BJT, FET, operational amplifier. Okay, that operational amplifier can be used in oscillators. Then you can also use it in amplifiers. But whereas a one-port network, you'll be using only in the passive elements such as RLC. Okay, there will be having only two terminals, right? So you are using in RLC, but here you can use it in what? BJT, FET, and then operational amplifiers. Okay, fine. So let me proceed with the first parameter, that is nothing but Z parameter. Okay, I'm taking into account my variables. Okay, my variables in the sense of V1 and V2. Okay, that is two variables which will be called as dependent variables. Then I'll be taking another two variables, that is nothing but I1 and I2, which is nothing but independent variables. Okay, so as mentioned earlier, the coefficient of independent variables. What is the meaning? Yes, this is the independent variable. This is the coefficient of independent variable. So that is nothing but Z11. That will be the first parameter. The next, you see this one, the coefficient of our next independent variable is Z12. So likewise Z21, Z22. So we'll be having 4 parameters, that is Z11, Z12, Z21 and Z22, right? So what I'm going to do here is, for the first case, I am going to make my I2 as 0 in the first equation. When I make I2 as 0 in my first equation, this term will totally vanish. So as a result, it will be having V1 is equal to Z11 I1. So as a result, what will be the value of Z11? Means it will be V1 by I1, right? So this is the case. I mean, the current is made as 0. That point is very important. In all the cases, the current are made as 0. That is very important. So the next one, that is nothing but Z12. So what I am doing here means I am making my I1 as 0. So when I make I1 as 0, this term will vanish, this will exist. So as a result of that, V1 will be equal to Z12 I2, which is nothing but what? Z12 is equal to V1 by I2. So this is a case when I1 is 0, right? Then what about the third parameter, Z21? Is they are making I2 as 0. Okay, when I make I2 as 0, what will happen? This term will vanish, this will exist. Okay, so I'll be getting what? V2 is equal to Z21 I1. So as a result of that, the third parameter will be Z21 is equal to V2 by V1. Finally, what I'm doing means I'm making my I1 as 0. So as a result of that, this term will vanish, this will exist. So that is nothing but V2 is equal to Z2 to I2. So what is the parameter Z2 value? Means it is V2 by I2, right? So these are all the 4 parameters. Okay, yes, that is nothing but coefficient of independent variables I1 and I2. So these parameters can be called as impedance parameter. Why it is called as impedance parameter? Means is ratio of voltage to current. All are ratio of voltage to current. If it is ratio of voltage to current, it can be called as impedance. Okay, it can be called as impedance. That's why it is called as impedance parameter. Okay, we all know very well that the unit of impedance is ohm. So that's what is represented here. Unit of Z parameters are ohm. So these are all the four important Z parameters. So here one important conclusion is there. What is that conclusion means? Is I am taking these two parameters Z11 and Z21. Okay, so when I take how I am calculating this means is I am open circuiting of port 2. I am open circuiting of port 2. That is what it is means is I will take the equation number 1 and then equation number 3. Okay, in both the cases I2 is 0. In open circuit current will be 0. 2 stands for port 2. Okay, that's what is given here. That's why the name reason. Okay, so likewise what happens means yes, the other two parameters Z12 and then Z22. It is called as open circuit of port 1. Okay, so Z12 is what? This one, and Z22 is what? This one. Okay, so this open circuit of port 1 means is the current of port 1 is I1, so that is made as 0 since it is open circuit. Okay, so that is the thing. Okay, so I framed two equations. Okay, from two equations I taken the values of different Z parameters, and then I had concluded how I am calculating the Z parameters value. That is nothing but I am open circuiting port 2 and then I am open circuiting a port 1. Okay, so that's why since I am open circuiting, that's why the Z parameters are called as open circuit impedance parameter. Impedance that is nothing but Z. So this is Z parameter. Okay, so what happens with the next one? Yes, sir. This is Y parameter. Y parameter is just opposite that of Z parameter. Okay, there we are open circuited, here you are going to short circuit. There we have taken impedance, here we are going to take admittance. Right, fine. So here what are all the variables? That is very important. There we have taken V1, V2. Here my variables are I1 and I2. That is nothing but dependent variables. Right. So you have another two variables, that is nothing but V1 and V2. That will be called as independent variables. Right. So quite opposite that of the first one. Okay, so here I'll be getting two equations as in the previous case, but in different way. Okay, there I got my V1 and V2, but here I'll be getting I1 and I2. So what is I1? I1 is nothing but Y11 V1 plus Y12 V2. That is my first equation. Then what about the second equation? I2 is equal to Y21 V1 plus Y22 V2. Same principle I'm going to apply for this also, but it is opposite that of the previous one. Right. So how to calculate the parameters, Y parameters, Y11, Y12, Y21 and then Y22. See, in the previous case we had calculated Z11, Z12, Z21 and Z22. So what we did there is we had open circuited, that is nothing but we had made the circuit as open and then the current is 0 there. But here I am going to short circuit. Okay, that's why it is called as Y parameters, otherwise short circuit admittance parameter. So condition for short circuit is voltage should be 0. Yes, I have taken that one here. Right. So what will happen? You see, first parameter is Y1. 1. How to calculate Y1? 1 is I am going to short circuit it. So I am going to make my V2 as 0. When I am making my V2 as 0, this term totally will vanish. This alone will exist. So I get what? I1 is equal to Y11 V1. So from that, Y11 is what? Is I1 by V1. So likewise for the second parameter Y12. So what I am going to do? I am going to take my V1 as 0. So when I am making my V1 as 0, okay, this term will vanish, this will exist. As a result of that, I1 will be what? Y12 V2. So ultimately my expression will be what? Y12 V2 is equal to I1. That is nothing but I will be getting the second expression. The same way I have to proceed for the third and then fourth one. Okay, right. So here the previous is Z parameter, okay, otherwise called as impedance parameter, but this is Y parameter, otherwise called as admittance parameter. Okay, why it is called as admittance parameter means it is a ratio of current to voltage. In the previous case it is a voltage to current, but here it is a ratio of current to voltage. Okay, that's why it is called as admittance parameter. Since it is impedance in the previous case, we have taken the unit as what? Ohm, but here it is admittance. You all know very well that the unit unit of admittance is mho, or else it can also be taken as Siemens. Okay, so I am taking my unit as mho, right? So how I am going to calculate, that is very, very important. Yes, in the previous case I had open circuited, that is nothing but I have taken my current 0, but here I am going to short circuit, that is nothing but I am going to make my voltage as 0, right? So how I am calculating, first Y11 and then Y21 is I am short circuiting port 2. Okay, what is the meaning for short circuiting port 2 means I take the V2 value as 0, that is nothing but this one and then this one. Okay, I am short circuiting the first one and then second one, voltage value is 0. Okay, so as a result of that I will be getting a Y11 and then Y21. Then what about the second and then fourth equation? Yes, second and fourth equation, yes, it is with respect to that of port 1. Okay, so what about the voltage there in port 1? It is actually short circuit, so voltage will be 0 in second and then fourth case. So as a result of that, what will happen means I will be getting the value of Y12 and then Y22. Okay, so same procedure of like that of the previous, but it is just opposite that of the previous one, right? So this is Y parameter. Next is hybrid parameters. Okay, hybrid parameters. Hybrid, it is going to combine the features of first two parameters. That is nothing but Z parameter and then Y parameter. Okay, fine. So here I am going to take my variables as V1 and I2. Okay, yes, it is combination of voltage and current. Okay, then what about the independent variables? Independent variable is I1 and V2. Okay, so we will be getting again two equations. But since it is a hybrid, I will have the combination of voltage as well as current in both equations. Okay, the first equation is what? V1 is equal to H11 I1 plus H12 V2. That is the first equation. Then what about the second equation? Means it is I2 is equal to H21 I1 plus H22 V2. Then what are the parameters? Yes. So here first parameter will be H11. How we are obtaining H11? Same as that of the previous two cases. Okay, I am going to make my V2 as 0. When I make my V2 as 0, this term will vanish. This will exist. That is nothing but V1 will be equal to H11 I1. So as a result of that, what is the value of H11? It is V1 by I1. Well, next is what? Yes, I am making my I1 as 0 and I am going to get the value of H12. So when I make the value of I1 as 0, what will happen? Yes, I will be getting the value of H12 as V1 by V2. So I have to proceed the same way for the next two cases. Okay, here what about the parameters? Yes, it is a combination of Z and then Y, so it is actually called as hybrid parameters. Okay, when you take H12 and then H21, okay, H12 and then H21, that is nothing but is second and then what it is third one. Okay, they are near numbers, ratio of two voltages. This is what actually ratio of two currents. Since it is a near number, it will not have any unit. Okay, but whereas the first case, that is nothing but ratio of V1 to I1, and then the last case ratio of I2 to V2. Okay, it will have its unit. So this is what it is, the formula for impedance. So I'll get the unit as ohm as mentioned in the slide. Then this is reciprocal, that is nothing but admittance. I'll be getting the unit as mho. Okay, yes. So we are calculating the parameters H11. Okay, then H21. Okay, that is nothing but first one and then second. Voltage 0. So that is nothing but a short circuiting of port 2. So in the same way I have to proceed with what? H12 and then H22. But I am open circuiting the port 1. Okay, so this is the H parameter. Well, what about the next one? Yes, sir. Next one is actually ABCD parameters, otherwise called as transmission parameters, otherwise called as T parameters. Okay, so this is totally different when compared to that of previous three cases. Okay, here V1 and then I1 will be the dependent variables, V2 and I2 will be the independent variables. Okay, then the coefficient, it is same. Okay, coefficient of what it is, this V1 and then minus, the coefficients of V1 and minus I2 will be called as T parameters. That is nothing but A, B, C, D. Okay, in the same way I have to proceed. Okay, that is nothing but when the value of I2 is equal to 0, what will happen? I will be getting the value of A. Next, you make the value of V2 equal to 0, I will be getting the value of B. Okay, then you make the value of I2 as 0, in the third case, I will be getting the value of C. Likewise, I will be getting the value of D also. So I will be proceeding like this and then I will be getting all my T parameters. That is nothing but A, B, C, D. Okay, so if you take A, B, C, D parameters. Okay, A and then D will not have units. A and then D will not have units. Why? A is a mere number. It is a ratio of voltages. D will also not have the unit. Why? It is ratio of current. Okay, so whereas B and C will have its own unit. Okay, so this will have the unit ohm. Okay, it is the formula for impedance, and this is the formula for admittance. I will be getting more for the third case. Okay, so how I am calculating the parameters? Yes, I am calculating my A and C parameters by open circuiting of port 2, A and C. Okay, A and C, that is nothing but where you have I2 as 0. Okay, so what about B and D? Yes, so I am short circuiting the port 2. Okay, yes, B and D, you take B and D. Okay, and short circuiting. So the condition for short circuit is voltage 0. So V2 is 0 in both the cases. So in that way I will be calculating all the parameters. Fine. Okay, so where you are using this? Yes, you are using this in transmission lines. Okay, normally transmission line will be having sending end and then receiving end. Okay, one port will be for sending end and other port will be for receiving end. So this is a very important parameter. Right. So this is the condition for symmetry and reciprocity. So what is symmetry? That is very, very important. So that was given the first point. Yes, the impedance measured at one port. I am talking about two port. Okay, impedance measured at one port will be equal to what means impedance measured at the other port. When it is equal, okay, then it will be called as symmetrical. Then you have a reciprocal. What is reciprocal? That is actually called as reciprocity. Okay, what is reciprocal means? If the ratio of voltage at one port to the current at the other port is same as the ratio when the voltage and current are interchanged. We are interchanging the voltage and current. Okay, then the network will be called as a reciprocal. That is nothing but condition for reciprocity. So this is the condition for symmetry and then reciprocity. I have taken all the parameters. Okay, yes, the first one is Z parameter, second one is Y parameter, third one is H parameter, and finally have T parameter. Okay, so for Z parameter, what is the condition for symmetry? The condition for symmetry is a Z11 equal to Z22. Right? Then what is the condition for reciprocity? It is totally different. It is Z12 is equal to Z21. Then next we will proceed with the Y parameter. For Y parameter, it is Y11 is equal to Y22. I mean condition for symmetry. Then condition for reciprocity is what? Y12 is equal to Y21. Okay. So likewise, you have the condition for H as lesser T. For H it is H11 H22 minus H12 H21 is equal to 1. That is condition of symmetry. Okay. Then for H parameter, what is the condition of reciprocity? Means H12 is equal to minus H21. Then finally for T parameter, condition for symmetry A equal to D, then condition for reciprocity for T parameter will be AD minus BC equal to 1. Okay, so these are all conditions for symmetry and then reciprocity. So this they are asking in the GATE exam. Conditions they are asking in the GATE exam. I have one question at the end. I will discuss. Okay, fine. So applications. Okay, applications are very important. Okay, so first it is used in circuit analysis. Yes, I told you in the very beginning itself. Okay, yes, all passive elements. Okay, that is nothing but resistors, capacitors, and then inductors. For representation of all these things, I will be using my network. Okay, then transmission lines. How it is used in transmission lines? Yes, I can characterize the propagation of voltage and then current along the transmission lines. Then in amplifiers, yes, I'm going to describe the small signal behavior of the transistors which are present in the amplifiers. Okay, network. In network, how it is used means in communication system, control system, mechanical and acoustic systems. Right. Finally comes electrical machines to represent transformers, to represent motors, and then generators. I'll be using this two-port network. Okay, so it is simple and then yet powerful two-port network concept. Okay, so it will be providing designers valuable insights into a system operation. Okay, it is going to relate what the input and then output. I mean the connections can be very well seen between the input and output. Okay, so these are all the applications for circuit analysis. We are using in RLC components, and then in transmission analysis we are characterizing what the voltage and current propagation along transmission lines. Then in amplifiers I'll be describing my small signal behavior of transistors and amplifiers. Then network, okay, in the network, communication system, control system, mechanical and acoustic system, okay, then electrical machines, very important, is for representation of transformers, motors and generators. I'll be using this one. Fine, right? So what about the conclusions? Is what I had explored through this extensive presentation is I had explored the definition, the parameters like Z, Y, H and then T, okay, then different conditions like what it is, reciprocity, which is nothing but reciprocal, then symmetry, all those conditions I discussed, applications in the previous slide I discussed. Then now I'm going to discuss the relevance for competitive exam. Competitive exam in the sense what? That is nothing but SSC. Okay, then AEJE, GATE, that is our scope, then ESC for all these examinations. Okay, so this presentation will be very useful. Okay, that's what is taken into account here. Then two more things I want to stress here, that is nothing but when you practice, whenever you practice, you'll become an expert in that. So here you see, regular practice of problems on two-port network parameters and analysis of complex interconnection configuration will help students and professionals apply these concepts proficiently. So you have to practice. When you practice, it will help both the students as well as the professionals like teachers to apply the concepts very efficiently. Okay, so this is a cornerstone topic. Where it is a cornerstone topic means in analog and then mixed signal electronic domains. Fine. So let me take the previous year questions. Okay, let me first discuss the one mark question. Okay, so this is a very nice question. A passive two-port network is in steady state. Compared to its input, the steady state output can never offer. I have to read out one more always very carefully. Okay, condition is given, a passive two-port network is in a steady state. Okay, two-port passive network is steady state. What is the question? Compared to its input, we are going to compare with input, the output, that is nothing but steady state output. See the question very carefully, can never offer, that is very important. Okay, so normally this will offer higher voltage, lower impedance, better regulation. All, option A, option B, option D. All will be possible with the given condition. But the third condition is not possible. Greater power is not possible. The explanation is given. Okay, so for the given condition, okay, A, B, D suits, whereas C will not suit. The question is what? Compared to its input, the steady state output can never offer. Okay, so C will not suit. That is nothing but a greater power. Okay, it can never offer. Okay, this condition can never offer greater power. Why this cannot offer a greater power is the explanation is given. Okay, it is a passive network. Passive network in the sense what? It will be consisting of only passive elements. Passive elements in the sense a resistor, inductor, capacitor like that. So you take the passive elements, that the passive elements cannot add energy or amplify the signal. So the output power cannot be higher than that of the input power. Okay, that is the meaning. Okay, see A, B and D suits for the given condition. See what is the question asked? Okay, which will not suit? That is nothing but yes, the steady state output can never offer. That is the question. So C will not suit. That is nothing but greater power. It cannot offer greater power. Why it is not offering greater power means yes, it is a passive two-port network. That is the keyword here. Okay, passive in the sense what? It will be having passive elements, RLC. So passive elements cannot add energy or amplify the signal. When it is adding the energy or amplifying the signal, it is never going to give better output when compared to that of input. Okay, so the option C suits for this question. Okay, then what about the next question? That is a very direct question. Okay, if a two-port network is reciprocal, then we have with the usual notation the following relationship. This is also one more question. Okay, which has been asked in GATE W 1994. So four conditions they had given. Okay, so the second condition H12 equal to minus H21 will suit. Okay, which will suit. Yes, sir. Whereas when you take D is something that condition for symmetry. Okay, yes, that we can see in the comparison table. Already we had seen that you can see in the comparison table. So here it is. So if you take the H parameter, condition for symmetry is this one. Okay, condition for reciprocity is this one. Okay, that's what is asked there. Okay, coming back to the previous, the second question, yes, you see. So, B is the correct option, that is nothing but reciprocal. Okay, you should be very careful. Okay, condition for symmetry is also given, but the question is only about reciprocity. Okay, it is reciprocal, so we'll be getting only H2 is equal to minus H2. Okay, fine. The last question is this is a 2-mark question. I have taken one mark question. I'm sorry, I have taken 1-mark question. This is a 2-mark question which has been asked in GATE 2000. Okay, it's a very nice question. The two-port device is defined by the following pair of equations. They have given 2 equations. What about their impedance parameters? They are asking us to calculate the value of impedance parameter. It is a direct application of the first parameter. Okay, they are asking Z11, Z12, Z21, and Z22. Fine. So they have given 4 options. Okay, answer is what is option B. That is nothing but 1, minus 1, minus 1, 2. Okay, we'll see the explanation the last slide. Okay, how you are getting this one? So please keep in mind, 2 equations are given. Okay, what is I1 and then I2? What they are asking means they are asking the parameters, the Z parameters, all Z parameters they are asking. Okay, they are given 4 options. We'll calculate it. This I'm taking the 2 equations, given equation. This is given I1 is equal to 2V1 plus V2. That is the first equation. Next is what? I2 is equal to V1 plus V2. That is the second equation. So what I'm going to do means I'm going to modify equation 1. I'm going to modify equation 1. Yes, I'm going to make this 2V1 as V1 plus V1. Okay, and the same as that of the previous. Okay, just I'm making 2V1 as what? V1 plus V1. Okay, next what I'm going to do means I'm going to substitute 2 in 3. Why I'm substituting 2 and 3? What is 2? Yes, 2 is nothing but I2 is equal to V1 plus V2. Okay, so in place of V1 plus V2, I'm going to substitute I2. I have substituted. But I am taking I2 that side, so I'll be getting what now? I1 minus I2 is equal to V1. Right? What about the equations that we had seen in the Z parameters? Yes, sir. So that is nothing but V1 is equal to Z11 I1 plus Z12 I2. Okay, so this equation we had seen what is Z parameters. Okay, so that I can get you now. Yes, see, V1 is equal to what? Z11 I1 plus Z12 I2. Then V2 is what? Z21 I1 plus Z22 I2. So that I'm going to take. Why? I have to calculate all these values. Okay, so for that I'm using that. Right? So coming back to the third question. Yes. So I'm using that equation here. Okay. So already I have equation 4. See, please visualize equation 4 and 5. It will be almost the same. So I can compare. Okay. So this is what actually I1 minus I2 is equal to V1. What is this actually? V1 is equal to Z11 I1 plus Z12 I2. Both are same. 4 equal to 5. I'm comparing. Okay. So I'll be getting what is I'm taking the coefficients. Okay. So Z11 is what actually the coefficient of I1 is 1. I'll get 1 here. And then how to get a Z12? That is nothing but the coefficient of I2. That is nothing but minus 1. So I'll get a minus 1. So I got the value of Z11, Z12. So the same way I have to proceed with the remaining 2 parameters. For that I'm again using the second equation. Okay, which is nothing but I2 is equal to V1 plus V2. Okay, so I'm modifying equation 2 in such a way that I'm substituting the value of V1 is equal to I1 minus I2. So I'll be getting I2 is equal to what? I1 minus I2 plus V2. Okay. Yes, you simplify this. So when you simplify this, you'll be getting V2 is equal to minus I1 plus I2. Okay. Now what I'm going to do means is I'm going to take the next equation what I had seen in Z parameter. That is nothing but V1 is equal to what it is Z21 I1 plus Z22 I2. Right? So I'm going to compare equation 6 and 7 and then I'll be getting the values of Z21 and then Z22. Okay, I'll be getting all my parameters. You have to proceed the same as that of the previous. Okay, yes, I'm going to do that. Okay, then I'll be getting the all 4 values. Okay, so here it is minus 1 and then 2. Okay, so previously I got what is 1 and then minus 1. Okay, so I'll be getting ultimately all 4 values, which is nothing but option B, 1, minus 1, minus 1. Okay. So, let me explore much more on it. Okay. Anyhow, I value all your time, and then I'm thankful for this opportunity. Thank you.